Guys and girls, it's Know-It time! Hey, let's get crack-lacking! It's Know-It time! Know-It time!
Alright, so let's get cracking. Today, I'm going to show you how to analyze functions involving x squared. Before, I'm going to give you a question. We had 3 over x plus 2 minus 6. That equals to y. Okay, that was before. Notice the highest power was to simply x. It gets a bit more challenging when I add in an x squared. For example, you get something called x squared minus 5x plus 6 all over x minus 3. I want you to highlight a few key things for me. Highlight this x squared. Okay. Once you see an x squared in there, the problem gets a lot more complicated. You're going to go through the whole process again, finding everything, but now I'm going to introduce a few more vocabs for you. 1. We're going to go through it and find your vertical asymptote all over again. Okay. Asymptote. So this is the process you have to go through when you have x squared. 2. I'm going to put a star beside 2 because here's a new one we're going to look for. This is called points of discontinuity. Oh, I blanked out for a second. I spelled this wrong. Continue. I'm missing a T. Ti. Continuity. 3. You need something called your x-intercept. 4. You need something called y-intercept. Now notice I left out your horizontal asymptotes. I left that out on purpose because once you deal with x squares, your horizontal asymptotes is going to be a lot more complex, so I'm not going to focus on it now. But the key is this new term, points of discontinuity. I'll show you what that is in 1 second. But first thing is vertical asymptotes. How do you find your Sergeant, how come nothing's copied down? How do you find your va? That's the issue. How do you find your va? If I give you a question like this, okay, let's go back to example. 3 over x minus 2. Okay, equals to y. I'm looking for a vertical asymptote. Keep it simple. And Patricia, what's your vertical asymptote going to be? X equals to 2. Why do you say x equals to 2? The denominator. See, one key thing you got to worry about is this. A vertical asymptote is a point where x does not exist. So let's write a few things down. A vertical asymptote is an imaginary line where x does not exist. Not exist. So if you put in 2 here, you have something called undefined. That's why your vertical asymptote is 2. So if I go back to my question, let's copy this on this question. Y equals to x squared minus 5x plus 6 all over x minus 3. I'm going to pause it. So a lot of you say, hey, vertical asymptote is x equals to 3. Let's write this down. X equals to 3. But I'm going to write this down. This is wrong. Because everyone's going to say the answer is 3, but this is wrong. Here's the reason why this is wrong. You cannot do vertical asymptotes until you cannot find vase until you simplify. Okay. Think about what I mean by that. I'm going to pause it and let you have. So if I look at this, I'm going to start simplifying. X minus 3, x minus 2, x minus 3. And when I cancel this out, that x minus 3 is gone. So really, my equation is simply y equals to x minus 2. Notice there's no more denominator. If there's no denominator, you have no vase, because there's no denominator. Vertical asymptote, as I said, is what x cannot be. Because I have no denominator, x can be almost anything. So look at this now. Your equation really becomes y equals to x minus 2. And Divya, what shape is that? Y equals x minus 2. Let's draw a line. I want you to draw y equals x minus 2 right now. Go. So remember, that's your y-intercept is negative 2. My slope is 1 over 1. So we're going to draw on a line. Here's the line. I draw a rough sketch. Now, so a lot of you say, hey, that's it, we're done. That's not it. We're not done. We have a lot more work to do. Because here's the next part. Because I said the hardest part is actually number 2. Points of discontinuity. And I'm going to write this down. P-O-D. That stands for points of discontinuity. Is a point that does not exist. Okay? Does not exist. If you want to think about it, it's like a hole in your graph that used to be there. So there's a point that used to be there until something happens. And I'll give you a hint, x equals to something. Where does that point occur? It used to be there until you got rid of it. 3. Because 3 is what I cancel out. So that's what point of discontinuity means. It means it used to be there, but now it's been discontinued. It's not there anymore. So what you're going to do is go to x equals to 3. And I'm going to say x equals 3 somewhere here. You're going to draw an open hole in your graph. It means there's nothing there. That is called your point of discontinuity. Sorry? If there's, I'm going to show you that in a second. Yeah, for now, we're going to keep it simple. That's called point POD. To find the exact value, here's what you're going to do. You're going to plug 3, because we want to know coordinates. My equation, y equals to x minus 2. Plug in 3 for x. That's 3 minus 2, so y equals to 1. So your point occurs really at 3, 1. That's called your point of discontinuity. It's the point that used to be there, but now it's, now it's gone. It's like a hole in your graph because we crossed it out. Okay? That's originally where your asymptote should have been, but it's not there anymore. To find that point, we sub 3 into my equation. X and y intercept you guys can do. Easy. But now I'm going to give you a question where you're not going to graph, you're going to analyze it. So here's your question. Y equals to x squared plus 2x all over x squared minus 4. I'm going to ask you a few key things. 1, let's look for PODs. Is there any PODs first of all? 2, and when I need PODs, I need to know the coordinates. So you're going to give me as a coordinate. 2, are there any vase? 3, I'm looking for my x-intercept. 4, y-intercept. Let's analyze this and see what happens. I'm going to give you a few minutes and see who can get far. I'm just going to simplify slowly. Sigmund, you have a question? What do you do to the top, Sigmund? What can you factor out? So you factor out, this becomes x plus 2. Gerline, what can you do to the bottom? X plus 2, x minus 2. So what cancels out, Gerline? X plus 2. So really what you have is y equals to x over x minus 2. Here comes the fun part. POD. The Tanvir, what's your x coordinate for your point of discontinuity? So what do we cross out? So what is your x coordinate going to be? X equals to negative 2. See, this is what I cross out. It means it used to be there, but now it's an empty hole at that point. But I'm looking for a y value also. So Prince, I'm going to ask you in a few minutes. Take a minute, and I want you to find the y value. Okay. So just using basic math, plug it in. So negative 2. Do you have an answer yet, Prince? Sorry? 0? Nope. 1/2? 1/2 is correct. Because I'm going to plug in negative 2 here. So you go y equals to negative 2 over negative 4, which is 0.5. So we know there's a hole in your graph at negative 2 and 0.5. Devesh, what is your VA going to be? X equals 2. See, look what remains. There's a vertical asymptote here now. So you're going to have x equals to 2. Go ahead, find your x-intercept, find your y-intercept. And I'm going to pause it again to give you a few minutes. Let's do this slowly. I'm going to start with the x-intercept if you're lost. I go x-intercept, I let y be 0. That equals to x over x minus 2. So Manraj, what's your x value going to be? Because I'm bringing this whole entire thing over. And that becomes a 0. So x-intercept is 0. So we go 0. Again, nothing too bad. Angelica, did you get a y-intercept yet? Kirsten, did you get the y-intercept? Okay. So let's do the y-intercept right now. We go y equals to 0 over negative 2. So Jordan, what's your y-intercept? 0. I put everything together now. Here's what I'm going to ask you in the graph. I'm not going to ask you to sketch it out because you're not ready for that's more of a calculus level. You're going to use these facts and you're going to tell me which one of these graph represents that equation. Graph 1, graph 2, graph 3. Which graph is it? Which graph represents what you just created? Okay, let's see. First of all, we know there is a POD at negative 2 and 0.5. Which one has a circle at negative 2 and 0.5? Well, look at this. That's the only one has it. There's a vertical asymptote we found to be at x equals to 2. Check this out. It has a vertical asymptote. Whoa. At x equals to 2. But this one has an extra one. This one doesn't have anything. You're going to go now answer this next question. B, 2x plus 4, x squared plus 1. Which one of these graphs represents B? Go through the whole process. This is what you expected to do on your exam. So now I want to look at B, 2x plus 4 over x squared plus 1. Which one of them represents that? Y equals to 2x plus 4 over x squared plus 1. Okay? Guys, gotta take a minute, find it, and I'm gonna pause it. Back to the drawing board. Set it up. See, if I look at this question, I can't factor out, well, I can factor the top. That gives me x plus 4, x plus 2. But the issue is, I can't do anything on the bottom. So right off the bat, there's no POD, because I didn't cancel anything. If I set this bottom to 0, because your vertical asymptote is based on your denominator. If I set it equal to 0 and I actually solve it, okay, you realize you can't do anything either. So therefore, there is no vase. And there's only one graph. No, that's square root of negative 1. There's no solution. That's called imaginary. So there's only one graph without any vase or without any PODs. So what you see. That's how you do this sort of thing. On your exam, I will expect you to show work and match the graph. That's what you're expected to do. The last one, right off the bat, you see there's, if you solve this, go solve right now, x squared minus 4, set it equal to 0, you get plus and minus 2. That's why there's two VAs, one here and one here. That's how you do this sort of thing. I'm going to give you one more question on this concept. What I have are 3 brand new grids with 3 brand new equations. Match up K, L, and M. I'm going to give you about 5-6 minutes. Right off the bat, I see a POD here and a POD here. So we know 2 of them has to have canceling out. I see a vertical asymptote here, none here. Something must have happened. So I'm going to pause it and let you have some. I'm only going to work with K of X for you guys because really it's all the same. I go K of X. Again, I am going to factor right off the bat. I go, no, this is going to be X minus 2, X plus 1. And notice one thing, nothing cancels out. So there's no POD. Because when I cancel it, it means it used to be there. But I know my VAs right away. VAs. X equals to Prabasi. What does X equal to? What's your VAs at? X equals to what? 2 and 1 more. So right off the bat, some of you say, hey, I don't need to do more, I can figure it out. Technically, yeah, you can. But I just want to make sure you push you a bit more. See, this is the only one with 2 vertical asymptotes. So I know this one has to be graph 3. But if you want, you can actually do the x-intercept and the y-intercept and all that fun stuff. And if you find, there's a reason I want you to find the x-intercept for me, go. Because there's a reason I'm going to ask you to do that. Of this one. And you're going to realize something. Find the x-intercept. Nope, x-intercept is not correct. Nope. If it's x-intercept, I let y be 0, right? I go 0 equals to... I know you're bad. So now what we're going to do, I'm going to move all the bracket over by just multiplying everything. So this becomes 0. So you have x squared plus 2 equals to 0. And if you look at this, you have an error. So no x-intercept. If I look at graph 3, it should not have crossed any x-intercepts. Look at that. It did not cross any x-intercepts. Okay. And there is going to be a y-intercept, which is at -1. You can do the exact same thing. You will have a y-intercept -1. That is your lesson for today, called Analyzing Functions. Your work. Well, too easy. Come on, guys. Come on, it's too easy. It's not. It takes away from the meaning of supernova to give you such an easy question. Hi. Page. Math 12 dinner? Yeah. No, lunch. It's a math 12. If you're a math 12. So, yeah. I hope you know what math you're. Page 452, numero 4, 5, and 6. Now I want you to write a few things from number 4. Do not graph. You can't do it yet. All I want you to do is find your POD, VAS, and X and Y intercept. Yep. For number 5 and 6, you're matching up the graph based on what I've taught you. Because on the exam, most likely, this 5 is going to be multiple choice. You should be able to figure out. And that ends your lesson for today.